Hi my dear friends, this is the confused physicist and let's get confused together. Here I will be calling out the importance of the independence of directions. In this video, I have discussed the mathematical importance of it. Have you not watched that? Please click on this I button and watch the full video of it. In that video, I had discussed that how I can isolate a problem in two independent directions, and that will save us a lot of mathematical complexities. But here, I will give you a more physical understanding of this idea. Remember, in the first video of my channel, I had conducted an experiment with an electron. Let's redo that experiment. I had an electron that was moving like this, such that I have measured its velocity very accurately. Now I want to measure its position at the same time. So I am watching it. I'm trying to measure it by looking at it. If I have to look at it, then I have to shower a light on it. While showering, a photon is coming out of this source and knocking out this electron to a different position. So if I have measured the velocity of this electron accurately, I won't be able to measure its position at all. This act of measurement is causing this velocity and position to be dependent on each other, right? So what's happening due to it? I'm losing information. Now suppose I have a classical analog to this problem, such that if I can measure one thing accurately, I will not be able to measure the other thing. I know it's a very hypothetical scenario, but let's consider it for it now. Then what will happen? I will lose information. In the classical theory, I lose information because of my own ignorance, but it is the problem of the experiment itself. I'm losing the information anyhow. So if I lose information, then the classical theory will transition into a probabilistic theory. I mean, the classical deterministic theory will transition into a probabilistic theory. But in the quantum setup, I always carry the burden of intrinsic probabilistic nature of the theory itself. So losing information is like a daily thing for quantum theory. I know quantum theory is difficult, but there's a good news for you guys. Nobody understands quantum theory, so relax. Now let's map this hypothetical scenario in the case of measuring coordinates. Just stay here. Suppose here I have an orthogonal set of coordinates like x and y. Now the problem is I can measure the coordinate only along the x direction, but I cannot measure it along the y direction. So I have a point, suppose here. Now I have measured its value along x direction to be a. Now due to problem, due to dependency of these directions, I can measure what's the value of b, right? Then the point can be anywhere along this line, right? Anywhere to infinity, I don't know. Okay, so this disturbs the utility of having a coordinate system. I won't be able to locate a point. Now coming out of this hypothetical scenario, if these two directions are dependent on each other, this temper with our informations, introducing many hurdles that I have to solve with rigorous mathematics. Why should I make my life harder? Remember, in the last video, I had asked you a question. Now, here I have two sets of different coordinate systems. One is an orthogonal, that is our preferred one, and here I have an oblique set of coordinate system. where the y direction is inclined at an angle 60 degrees to the x direction. Now, while measuring the location of a point in this orthogonal setup, I was drawing a straight line perpendicular to the x direction, and just notice that this line is parallel to the y direction, right? But this complication arises when x and y are dependent on each other. How? If I have a point and if I have to locate it, I can drop down a line perpendicular to x direction. And I threw a question at you guys that what if I had drawn the line parallel to the y direction? Then the problem will arise if this is a and this is a dashed. Then this point will correspond to two numbers, a comma b and a dashed comma b. So the uniqueness rule will be broken. Is it? Is it so? No. The problem is these are the two different ways of measuring. Okay. This measurement belongs to a different space and this measurement belongs to a different space. Like, I have two names. By one name, my colleagues or friends call me, and there is another name that I call my nickname that my family members used to call me and my close friends call me. Likewise, these are the two measurements. The names belong to different conditions or places. Likewise, these two measurements belong to different spaces. Still, in each space, I have a unique way to look at a point. The uniqueness is not disturbed. But what is disturbed is the independence of the system, and that is creating this complication. Now, I don't want these complexities in my life. That's why orthogonal setup is a smart preference. Now I want to replace the rule 2 I introduced in my previous video. I told that the rule I need to form a relevant coordinate system is an orthogonal setup, but the physical needs tell me that I need independence of measurement of the coordinates. So the rule 2 should be independence of the measurement of coordinates. Okay, or just simply I can write it independence of directions. So if you like this kind of videos, please subscribe right now. Drop a like, comment down below. Each of your views, likes, comments and shares just motivates me and I need it. Please subscribe right now. I'm making these videos for you guys to share my experience with physics. If you like it, please do subscribe. Please, I need it. This is Anubhav Datta and I am signing off.